Hi, my name is Juan, and I'll be introducing our topic for ENG 2003. Our presentation is on solving the intermittent characteristics of renewable energy. To explain why this matters, we need to start with the bigger picture. Experts like William Ryerson and Jim Watson say sustainability isn't just about protecting the environment, it's also about human health and fair access to energy. As energy demand continues to grow, especially in developing regions, we need clean energy that works all the time, not just when the weather is right. So, what exactly are these renewable energy sources we're talking about? Renewables like solar, wind, and hydro are clean and naturally replenished. They're a great alternative to fossil fuels, but they're not constant. Solar panels don't work at night, and wind turbines need wind to generate power. And that leads us to one of the biggest challenges with renewables: variability. The power grid has to stay balanced. If there's too little energy, we get blackouts. If there's too much and we can't store it, then that extra energy is wasted. In Germany, during an event called Dunkelflaute, both sun and wind generation dropped heavily for 2 days. As you can see in the graph to the left, renewable output fell to less than 10% of capacity, forcing the country to bring back fossil fuel plants just to keep the grid running. To prevent this, we need strong storage systems and better ways to handle long gaps in renewable energy, which leads us into our problem statement.
And today I'm going to talk about the problem statement on storage limit renewable growth. Hi, so for this slide, I'm going to show why solar and wind are not 24/7. On the left, you can see here's a California dark curves as solar grows. The midday dip get deeper, and on the evening, the ramp gets deeper. Like without the storage, grid operator dump clear all power at noon and then scramble at after sunset to meet demand. On the right, we can see here's a German winter dark flow, literally dark the room. Wind and sun can drop to under 10% for about 48 hours, and in winter, those loops can last week during the scratches. This state of charge just drain unless we have a long duration storage. I'm going to talk about why storage is bottleneck. On the left, IEC said grid need 1,500 GW for storage by 2030, about 1,200 GW in batteries or real phase containment or slow connection. And also here's some for example, like first one, California dump 11.5 of solar, Great British North Island contain 10 to 30% wind in the Mongila 641. And Texas is 6.9 GW battery output by run out of duration.
And now, on to the main content. So what is a flywheel? A flywheel is an energy storage system which stores rotational kinetic energy by spinning a cylinder about an axis. The formula that represents this stored energy is 1/2 of the moment of inertia of the cylinder multiplied by the square of the angular velocity. During energy surplus, the flywheel is spun up by a motor, and during energy deficits, the motor acts as a generator, feeding power back into the system. Here is a diagram showing common components found in most flywheels, these being a vacuum enclosure, magnetic bearings, a cylindrical rotor, a hub, a shaft, and a motor/generator.
Flywheel energy storage offers several advantages. First, longevity. Systems can operate for around 20 years before needing to be replaced, achieving more than 150,000 full charge and discharge cycles. Second, power density. Transportation trials have roughly shown a 2.7 kilowatt hour per liter power density, which is significantly higher than lithium-ion battery storage. Third, responsiveness. Flywheels follow dispatch signals of about 100 times faster than traditional energy generation sources, making them excellent for grid stability and services. They also have low operating costs and are very easy to maintain due to their relative simple makeup and upkeep. Finally, they are environmentally friendly and can be made from renewable resources. However, there are some noteworthy drawbacks. The initial capital requirement is high. A US utility scale power plant of about 20 megawatts with composite motor rotor systems costs upwards of $50 million to manufacture. This was about double the cost of a battery power plant. Flywheels also discharge rapidly. Energy leaks away faster than many other traditional forms of energy storage. They are not ideal for holding energy over long periods of time. Lastly, while they deliver high power, the total energy stored within the system is comparatively low versus other forms of energy storage.
Flywheels are a great solution to the grand challenge due to many factors. They are sustainable and store energy in an easily accessible manner. They can be used to compensate for dips in energy production, as the energy they store is immediately accessible. This makes them ideal for residential and commercial applications where consistent and stable energy supply is critical. The inconsistencies come from the intermittent nature of energy sources such as wind and solar. Aside from electrical grids, flywheels have other applications. Flywheels can be used to power vehicles such as buses and other scheduled transport vehicles. This can be used to offset the emissions created by vehicles during operation and reduce our reliance on chemical batteries.
Hi, I'm Derek, and I will be discussing how flywheels can help store abundant energy for later. The way a flywheel energy storage system works is very simple. We start with an abundance of energy from renewables, and this energy is used by the motor to spin the flywheel, storing kinetic energy. When the energy from renewables don't meet the grid demand, discharge happens, where kinetic energy stored in the flywheel rotates the motor to generate electricity like an alternator, and is then supplied to the grid. The flywheel system can store energy for hours, which is good for tackling intermittent problem for renewable energy. However, because of its low energy storage capacity and rapid discharge, it's not suitable for long-term storage. Think of it like storing food in the fridge. Good for short-term storage, but food can eventually go bad. Energy Astro, a French startup company, has implemented this technology along with solar-powered systems to combat the intermittent problem in developing countries. To know the true potential of flywheels, more research and funding is needed. We recommend further research in laminated steel because of its low cost and high energy density. We think this could be a key in the further development of flywheel technology. Other popular potential pathways include lithium batteries, which are cheaper but face more wear and short life cycles, as well as pumped hydro, which can store more energy for longer but cost more and require water. To conclude, renewable energy is intermittent. A flywheel is a mass that spins to store kinetic energy. Some of the attractive features of flywheels is that they are long-lasting, require low maintenance, are power dense, and are quick to respond. But their high startup cost, low energy capacity, and rapid discharge make it unattractive. Flywheels are great for storing excess renewable energy short-term, but not good for long-term storage. So when we ask ourselves, what is the point of this? Well, it's to preserve the beautiful place we call home. Thank you very much.